This is a video about pH. pH, as the title says, is a measure of acidity. Remember, in the previous video, we talked about some of the characteristics of an acid and the characteristics of a base, and we had also discussed the reaction in which, but we actually discussed the definition of an acid and the definition of a base. And pH is a measure of a solution's acidity. pH, mathematically speaking, is a created idea. It's an idea that is created. It's not a natural type of relationship. It is a man-made type of relationship. And it's based upon a base 10 logarithm. And pH is equal to minus the log of the H plus concentration. Remember, we said that although in reality it's the H3O plus ion that exists in the solution, if we just look at the H plus ion in terms of the proton being donated or being accepted, we can look just at the proton or H plus concentration, and the pH is minus the log of that H plus concentration in the solution. Now remember, every solution, because water auto-ionizes, has H plus concentration and an OH minus concentration, and therefore pH can be measured for any solution or anything that deals with water. And of course, if we add something that is acidic or acts like an acid to the water, then that H plus concentration goes up. And if we add something that acts like a base, then that the H plus concentration goes down and the OH minus concentration goes up. Now, solution is, according to this chart, neutral when the H plus concentration equals the OH minus concentration. You may have heard in the past that the term that a solution is neutral when pH is equal to 7. Well, that's not exactly accurate. What's the reality of it is that the H plus concentration has to equal to the OH minus concentration. At 25 degrees Celsius, that concentration for the H plus is 1 times 10 to the negative 7th moles per liter. And of course, therefore, if the H plus concentration is 1 times 10 to the negative 7th moles per liter, the OH minus concentration is also 1 times 10 to the negative 7th moles per liter. And of course, if you remember from the case of W, the case of W is equal to, at 25 degrees Celsius, 1 times 10 to the negative 14, which would mean that since these two concentrations, the H plus and the OH minus, are 1 times 10 to the negative 7th, that would seem to make sense, because 1 times 10 to the negative 7th times 1 times 10 to the negative 7th comes out to be 1 times 10 to the negative 14th. And so the concentration of H plus at 25 degrees Celsius is 1 times 10 to the negative 7th. Therefore, if we plug that value into the pH equation, the pH comes out to be 7. So the pH of a neutral solution is 7 only when it's at 25 degrees Celsius. But in reality, the H plus concentration must be equal to the OH minus concentration, which will be true for any neutral solution, but it can be at different temperatures. So if it's at a different temperature, these concentrations will be different. They'll still be equal to each other, but they won't be 1 times 10 to the negative 7th. And therefore, what happens is that these two concentrations are equal to each other. The solution is neutral. The case of W is no longer 1 times 10 to the negative 14th. So these two concentrations will no longer be 1 times 10 to the negative 7th. And therefore, since the H plus concentration isn't 1 times 10 to the negative 7th anymore, the pH is not equal to 7. A solution is acidic when the H plus concentration is greater than the OH minus concentration, as we stated earlier. Therefore, the H plus concentration now has to be greater than 1 times 10 to the negative 7th. And when that is true, the pH is going to be equal to less than 7. So any pH less than the value of 7 is going to be acidic. And usually, it ranges from less than 7 down to 0 on the pH scale. Although pHs can be less than 0, it is possible. But for most dilute solutions, the range for acidic solutions falls between 7 and 0. For a basic solution, the H plus concentration is less than the OH minus concentration. And if that's the case, the H plus concentration is less than 1 times 10 negative 7th, and the pH becomes equal or greater than 7. So the pH becomes greater than 7. Anything greater than 7, usually it's between greater than 7 and 14 is the usual case for most dilute solutions. Although the pH can be greater than 14. In most cases, it's between 7 and 14 for basic solutions. So the pH range generally goes between 0 and 14. As the pH goes up, the H plus concentration must go down. Let's take a look at this example. What is the pH of a solution that has an H plus concentration of 1.6 times 10 to the negative 6? Well, here's our equation. We're going to plug in the value of the H plus concentration. We're going to hit minus the log and put in the number, and it comes out to a pH of 5.8, which means this pH is somewhat acidic. Here is the pH meter, the best and easiest way to measure the pH of something. We don't have any pH meters, unfortunately. We have some little probes. Don't work very well, but we don't have any good pH meters. And here's a list of some different common substances in which you'll find the pH values. Gastric juice, which is a common substance only from the fact that everybody has a stomach. Lemon juice, vinegar, grapefruit juice, orange juice. You can see all of these things are acidic. Urine has a range of about 4.8 to about 7.5, so urine is usually acidic. And water that's been exposed to air, water is usually acidic. Saliva, slightly acidic. Milk, slightly acidic. Pure blood should be, or pure water, excuse me, is about 7. Blood has a range of 7.35 to 7.45. And of course, as we go down further, milk of magnesia, which you may or may not be familiar with, it's a medicine for sick stomachs, is a pH of 10.6. Now, counter to the pH is something known as the pOH. The pOH is equal to minus the log of the OH minus concentration. So that is counter to the H plus concentration times the negative log, or not times the negative log, taking the negative log of the H plus concentration, which gives us the pH. Of course, as you know, both of these can be measured for any aqueous solution or pure water itself because of the fact that there's always H plus concentration and there's always OH minus concentration. Remember, the H plus concentration times the OH minus concentration is equal to the K sub W, which at 25 degrees Celsius is 1.0 times 10 to the negative 14. If we take minus the log of everything in this equation, we get minus the log of the H plus concentration times minus the log of the OH minus concentration is equal to minus the log of 1 times 10 to the negative 14, which turns out to be 14. Since minus the log of the since minus the log of the H plus concentration is the pH, and minus the log of the OH minus concentration is the pOH, it turns out that the sum of the pH plus the pOH add up to be equal to 14. Which is really useful because if we knew the pH, we could find the pOH in a certain situation, or if we knew the pOH, we can find the pH. The pH of rainwater collected in a certain region of the northeast United States on a particular day was 4.82. What's the H plus concentration of the rainwater? Well, pH is equal to minus the log of the H plus concentration. Now remember, we don't want the pH, we want the H plus concentration. Rearranging that equation, we see that the H plus concentration is equal to 10 to the minus pH power. So all we have to do is raise 10 to the minus pH power, and we get the answer. So it's 10 to the negative 4.82 since the pH was 4.82. And the H plus concentration comes out to be 1.5 times 10 to the negative fifth moles per liter. The OH minus concentration of a sample of blood is 2.5 times 10 to the negative seventh. What is the pH of the blood? Well, we've got the OH minus concentration, and we know that the pH plus the pOH is equal to 14. So if we knew the pOH, we could subtract it from 14 and get the pH. So let's use the pOH is equal to minus the log of the OH minus concentration. And we plug in the number, which is the OH minus concentration. We turn the crank, and we get the pOH as being equal to 6.60. And then all we have to do, of course, is knowing that the pH is equal to the 14 minus the pOH, because the pH plus the pOH is equal to 14, so that the pH is equal to 14 minus the pOH. We subtract 6.60 from 14, and we get the pH. And that's the end of this video. So we're going to stop right here. We're going to end this video, and we'll see you guys in class tomorrow. Have a good one.